In this video, I will now show you how to do an independent sample t-test using a cut point versus groups. So you may want to watch the video about how to do a t-test in groups before this one, just because it gives you more detail on what we're looking at. Here I will just focus on using a cut point. So we'll go under Analyze, Compare Means, Independent Sample T-Test like we did before, because we're comparing two separate groups, two independent groups, and how they differed on their means, their averages. In the case that we're going to do, their average rating of something. Okay, so I'll just hit Reset. So we remember that the testing variable has to be a scale variable, which is the rulers. So let's say I want to look at an importance rating about whether the golf course is easy enough for me. I will throw that over in the testing variable. Okay, so your testing variables always have to be scale variables because that's what you're doing your mean on. And you can only do a mean on numbers that make sense. So an interval or a ratio variable, which SPSS calls scale. Our group, on the other hand, is going to be a nominal or ordinal variable. So let's say I want to cut it at a certain age point. So you can see that is a ordinal variable because it's denoted by the bar chart icon. So I'm going to throw that in as my groups. Now I have two options. Like last time, I could just pick two of my various age groups and compare them against each other. Or if I didn't want to alienate the rest of the age groups and by just looking at two individually, I can actually use all the age groups and just cut the data somewhere so that it creates two groups. Okay, so why don't I look at how the variable's set up so we can make that decision. I can explain a little better. So if I go to Variable View and I go down to Age and see how it's coded, well, I can see here that you've got a coded value of 1 is under 18, 2 is 18 to 24, and so on. Uh-oh, there's a prefer not to answer here, but I can see in my missing value that 8 has been coded as a missing value, so that's good. A prefer not to answer, you'll likely want to choose that as someone skipped the question or missed the question, so it should already be coded in your data set as a missing value. So really we can ignore that 8 and just go up to 7 here, which is 65 or above. Let's say I were to cut the data at 5. What this would do is it would include everyone younger than the data point 5 and then 5 and everyone above. Okay? So if I cut the data at 5, it's going to make two groups for me that I can then compare. It's going to take everything less than 5, so 1, 2, 3, and 4, so I'm going to be 44 years old or less compared to a group of 5, 6, and 7, which is 45 years old or more. So there's my two groups, 44 and less than 44 years old, and 45 and older than 45. Whatever number you choose as your cut point will go with the higher group. Okay, so now that I know that, and let me pick a variable. We already chose the variable of whether the golf course is easy enough and how important that is. I'm just going to check on that. Okay, good. That was a 1 to 5 scale. I now know whatever average rating that I look at, I can know it was a 5-point scale. So again, I will go to Analyze, Compare Means, Independent Sample T-Test, and how important is it that the golf course is easy enough for you? That's my test variable. It's got the ruler. My grouping variable is the age, and I'm going to define my groups, and instead of choosing two age groups to compare to each other, I'm going to cut my data so it includes all the groups, but it's just cut somewhere which can create my two groups, because again, t-test you can only look at two groups against each other and how they differed on their mean of something else. So my cut point I chose was 5, which was going to give me 44-year-olds and less and 45-year-olds and more. Continue. Okay. So, as we saw last time, the N denotes how many people answered the question. So, there was 174 people over 45 years old and older that answered the question. and there was 41 people that were 44 years old and younger that answered the question. Their rating on a 1 to 5 scale, well, the older folks, 45 years old and older, rated at 2.91 on a 1 to 5 scale, and the younger group, 44 years old and less, rated it as a 2.93 on a 1 to 5 scale. So you can see here the younger group had the higher rating of whether it is important and the golf course is easy enough. Okay, but it was only higher by 0.02. Okay, so not a big difference there. 2.02 points difference. Okay, but let's go ahead and check out if this is statistically significant. Well, as you can see here, there's 3 different significance levels that SPSS gives you on a t-test. The first one is your Levine significance, and the next one is the actual significance that's important for the t-test, but there's 2 of them. How do we know which one to read? Well, the Levine's test is testing for equal variances or not. So this test, this first significance, just tells you whether to look at the above row or the below row. So we know that a significant value is less than 0.05, so this is above 0.05, 0.881. If it is above 0.05, you look at the above row. You can assume equal variances, and this is the significance, the 0.941 that matters to you. If that was statistically significant, so below 0.05, then you look at the below row, which is not assuming equal variances, which is your 0.944. But this is above 0.05, the Levine significant level, so we're going to read the above row. So your t-test significance is 0.941. That is not significant. We need it to be less than 0.05 to be significant. Therefore, this age group at this cut point, 44 years and younger and 45 years old and older, there is no statistical difference between whether they think it's important that a golf course is easy enough for them. So this is something that we would not show the client because it's not statistically significant. We need t-test to be statistically significant. So as soon as we see that the t-test is not significant, then we can end there. Okay? There's no relationship. However, if it was statistically significant, if we wanted to know the difference between the 2 means, we would simply look up here and we can see that the difference is 0.02, because if we subtract the mean of the one group subtracted by the next, that's a 0.02 difference between the means. But again, this is not statistically significant, so we could stop before we even looked that far. So that is how to do a t-test based on a cut point versus 2 separate groups. If you haven't watched the video on how to do a t-test with 2 separate groups, you might want to check that out as well.